Good day everyone, today we are going to talk about non-parametric techniques. What is non-parametric techniques? By definition, it is a set of algorithms that do not make strong assumptions about the form of the mapping function. What are the differences between parametric and non-parametric techniques? For the parametric, it requires specification of some parameter to make predictions, while non-parametric do not rely on any specified parameter setting. Parametric is simpler to interpret but constrained. Non-parametric is more complex but can result in good performance. For parametric, less dataset is required so that it is faster. For non-parametric, it requires more dataset so that it is a lot slower. Here are the examples for parametric techniques. Logistic regression is a statistical analysis method to predict binary outcome. Linear regression is a statistical analysis method to predict the relation between two variables. Naive Bayes is a probabilistic algorithm that's used for classification problem. And here are the examples for non-parametric techniques. Decision trees is an algorithm that is used to categorize or make prediction based on how a previous test or question was answered. K-nearest neighbor is a classifier that uses proximity to make classification or prediction about the grouping of individual data points. Support vector machine is an algorithm used for both classification and regressions.
What are the two types of non-parametric methods? We have two methods. The first one is generative and the second one is discriminative. Here I will show you the difference between them. In the generative, we have to understand how data is embedded into the space. Predict depends on joint probability. Need enough data to have best performance. But in the discriminative, you divide data into classes by learning the boundaries. Predict depends on posterior probability. Work well with small dataset. As an example here, you can look to the question. We have four samples. In the prescriptive of the two model, generative model, the sum of function p x comma y equals 1. Then the discriminative model, sum of the probability of event x given the event y has occurred equals 1.
Besides that, let's talk about the Poisson window. Poisson window, also known as a kernel density estimation, a non-parametric way of estimating the probability density function of a random variable. Next, let's talk about the equation of Poisson window. First, the general expression of non-parametric density estimation has the equation is Px congruent to K over Nv, where V is the volume surrounding X, N is the total number of example, K is the number of examples inside V, and suppose that the region R that encloses the K examples is a hypercube with sides of length hash centered at the estimation point X, which D is the dimension. Then its volume is given by Vn equals to hash n power of D. Hash n is equal to length of the edge of Rn. Then we define a hypercube window function phi u, which is an indicator function of the unit hypercube which is centered at origin. Phi u is equal to 1 if modulus uj smaller or equal to 1 over 2. Otherwise, it's 0. The number of samples in this hypercube is kn equals to sum of phi bracket open x minus xi over hash n bracket close. Now, the estimation equation from this Pnx congruent Kn divide n over Vn turn into this. The Poisson window is estimation equation. Pnx equals to 1 over n sum of 1 over V and phi bracket open x minus xi over hash n bracket close. In Poisson window estimation, the equation expresses the estimate for Px as an average of function x and the samples x.
Here is the k-nearest neighbors estimation. You can also call the k-nearest neighbor as k and n. So basically, kn is a supervised learning classifier. It can be solved for both classification and regression problems. There are two ways to calculate the distance between 2 points. The first is Euclidean distance, and second will be Manhattan. But the most commonly used is Euclidean distance. So you probably will question what is the difference between Poisson window and k-nearest neighbor. So what is the difference? For k-nearest neighbors, it selects kn to determine its decision boundary. For Poisson window, it selects a constant value radius, which means that all points within that radius are considered as the neighbors. So here is an example for kn estimation. There are three colors of the points. One color represents one class. So blue color will represent as class 1, orange will represent as class 2, green will represent as class 3, and the gray point in the middle is the K. Next step, we need to draw a line between every point and K to clarify the distance which is the longest or shortest. And we need to arrange them from the shortest distance to the longest. Then if our K value is 6, then we calculate from the top 1 to 6. And from 1 to 6, there are 3 blue points, 2 green points, and 1 orange point. So which means that the majority is the blue points among the first 6 points. And we choose which color points with the majority. So to conclude that, when your K value is small, it's low bias, high variance, and overfitting. When your K value is large, it's high bias, low variance, and underfitting. So the optimal K value is to control the balance between overfitting and underfitting.
So, what is the nearest neighbor rules? The nearest neighbor rules, or NNR for short, these are a group of algorithms widely used in classification and regression tasks. You see, the core idea behind NNR is that similar data points should have similar labels or values. So imagine you have a new unknown data point and you want to figure out its label or value. What NNR does is it looks for the most similar data points in the datasets, also called neighbors. By examining these neighbors, we can determine the label or value for the new data point. It's a simple yet powerful concept that has proven to be effective in many applications. Now, let's dive deeper into how NNR works and its various applications. The nearest neighbor rule involves finding the nearest labeled data point in a dataset represented as the n to classify an unknown data point represented as x. By measuring similarities like Euclidean distance, we predict x's label based on the closest neighbor's label. It is simple yet effective method in classification. In conclusion, the nearest neighbor rule serves as a remarkable method for classifying data points in pattern recognition tasks. While it's not be flawless, as it can struggle with intricate patterns, high dimensional data, or noisy datasets, it still holds its place as an invaluable tool in the pattern recognition domain. By striking a balance between simplicity and effectiveness, the nearest neighbor rule continues to be a go-to technique for many classification problems.
Thank you and have a nice day.